Ano ko yun, no? Mataba to, I had to take away.
Perfect. Good morning, everyone. Good afternoon. Welcome to our 9th session of our educational program for municipal governments in Belize from the Recycle Organics program. We're happy you are all here. Let's see if everyone has been able to come in. Yes, that's good. Perfect. So for our session today, we're going to focus on a topic that we haven't really talked about before, which is the link to the agro-industrial waste in Belize. So leading organic waste transformation, circular solutions for agro-industrial waste in the country. We have a couple of interesting case studies and an initial presentation to share some things with you of our event that we had last month. We'll start as usual with this welcome and then a Mentimeter. We had shared with all of you our last month or in September, since we didn't have a session in September, just a couple of links to interesting things you could take a look at. So that our Mentimeter today is going to be a little bit focused on that. So if you took a look, then you'll be able to answer. If not, not. So we'll see how that goes. And then we didn't have a session in September because we were in an in-person event with all of our beneficiary countries under the Recycle Organics program in SITS. And so for our first presentation today, or our first speaker, we'll have Joyce Cantun from Orange Walk, our sanitation counselor in that town. That was in that event, and that'll share a little bit of insights on her part, share with you what the event was, how she participated, and what she got from it, so that you all can also have a little insight into what happened during that event. Then we'll get into the topic of today's webinar. The first presentation is agroecological farming, how farms can feed the earth and not deplete it. Then the second presentation will be an example from Samoa, farmer training in biodigestion, which is a topic that we haven't really covered in our webinars so far, so a new topic for today. And then producing compost utilizing sugarcane processing waste streams from the sugarcane industry in Belize. And then we'll close with the Q&A and the closing remarks as usual. Good. So let's move ahead. We'll start with the Mentimeter, and for that, I'll welcome Maria Paula, who will lead this part of the discussion. Go ahead, Maria Paula.
Thank you very much. Good morning, everyone. I was allowing all to have your cameras and your microphones in the case you want to turn off your cameras. So yeah, as Diana mentioned, on September, we couldn't have these webinars. So for that, we give you some homework. That homework, more or less, it was trying for you to see a publication, to review a publication, and also a webinar. That was the email that I am showing you in the screen, and also below you can see the webinar in the right side and the report on the left side. So now we will have some small or short questions for you to review the content, or maybe the case studies, or also have the time now to understand more what was about that two different materials that we share with you. So for that, I will please say if you can scan this QR code. In the case you can't, you can get into the Mentimeter website. I will leave you the link on the chat. In the chat, and the code to get into the Mentimeter, it's 2686-8520. So let me know when you are here. I can see that 3 persons had joined. Give me 1 second. Can you see now the Menti? Can you confirm that you can see the Menti now? You can't, so I will share again my screen. So the idea is to answer only 3 questions related to the report and the webinar that we have shared with you on September. In the case you didn't see, or even you didn't read the report, you can, the questions are easy, so you can see more or less what are the reports and the webinar about. Okay, so we can start now. We are 6 people in the Menti. The first sentence is about, please indicate the country from which the case studies were presented during the Recycle Organics webinar, unveiling success in organic waste management. This was one of the webinars that I shared with you in September. On September, you can choose the country. In the case you saw the webinar, you can answer positive, in a positive way, or in the case you didn't, you can just say what you think. So it's Samoa, it's Grenada, it's Fiji, or it's Guyana. No one is voting? Are you scared? No, you can vote. You can choose the option you think it was about. One answer.
Guyana. Let's say Guyana.
You say Guyana. Let's see, let's see. I will wait for 2 more responses. Let's see. Are you voting? 2 more people? No? Well, I will move forward to the next one, but the correct answer is Fiji. It's here, so but don't worry. You can see the webinar beforehand, and then you can answer properly. Now we have this second question that it's more related to the technologies or the organic waste management initiatives. Which of the following technologies were not described in the report Organic Waste Management Initiatives? It wasn't described, or they were mentioning composting, they were mentioning anaerobic digestion, black soldier flies, or hydrothermal carbonization. You can choose the option that you think that this report didn't mention. Of course, it's trying to figure it out. Or maybe understanding by context which of the following technologies that you can see on the screen, it's maybe not the more sustainable for the waste. 3 people voted hydrothermal carbonization. So I will say it's okay. And we can move to the last one. That is a household waste characterization by Lautoka City Council from Fiji found that 55% was organic, leading them to what of the listed actions they should, or they had taken because they need to do something with the organic waste, with the 55% of the organic waste. Maybe they promote burning as a practice to reduce organic waste. You think that should be the correct answer? Or maybe they ask residents to separate organic waste from stray animals. One of you is saying that the correct answer is promote composting practices as a way to reduce waste. Maybe that is the correct answer. Or ask the residents to sell their organic waste to a private company. Could be an option, why not? But what the council decided was to promote composting practices as a way to reduce waste. So thank you for participating. I will be back again to give me 1 second, to the PowerPoint so we can start right now our presentations. So as Diana mentioned, first in our agenda, we will have the words from Joyce Cantun. She is the sanitation counselor of the Orange Walk town, and she was selected from the Recycle Organics program to participate in the final event of this project that is being developed in 6 different seats. So some representatives from each country traveled to Florianopolis sorry, on September, between the 23rd and 25th of September. We traveled to Florianopolis, that is an island as well in Brazil. So Joyce will share with you some some insights that is she here? Are you here, Joyce?
Yes, all right. Yes, I am here. We are here.
Okay. So I give to you the floor.
Hi, good morning, everyone. You could hear me all?
Yes, we can.
Yes, we
Okay,
can.
okay,
I think we
good.
can't see you. You can? I can't. Do you have your camera on, Josie?
No?
Now. Perfect.
Okay. Well, good morning, and thanks for the opportunity given to us at the Orange Rock Town Council to be part of this workshop. And these 3-day workshops that was hosted in September 23rd, 24th, and 25th in Florianopolis was very impactful, meaningful, full of knowledge and networking with the Caribbean and the Pacific small island nations. It was a great learning experience and opening experience for me, since this is all new to me. I had no what is composting, since I do composting at home, but very little. It's only from my organic waste, but now at a larger scale, seeing it at Florianopolis, it was an eye-opener, and it's practical, cheap, affordable ways that we can implement here at the Orange Rock Town Council. Since Orange Rock has around 32% is organic waste from our entire garbage that we collect, our number 1 duty as the Orange Rock Town Council is to pick up residential and business garbage, no? We do not charge a fee on that. And what was surprising is that hearing from the other Caribbean countries is that they do not also charge for the pickup of their residential or residential garbage fee. They do not charge that either. So that is a bigger expense on the town council or city council itself. So finding a way in how we could divert the organic waste from it going to the landfill and doing becoming circular economy. I learned more about the circular economy and how we could, divert that and turn it into a lasting, rich product where we could sell it as well, and also our farmers could use it here, because we're big in agriculture here in Belize. So one of the main things that stood out at Florianopolis at the 3-day workshop was very cram up with a lot of panel discussions, hearing about the other experiences that the countries have, and being that we are all small island nation. Belize is still a Caribbean country, part of the Caribbean. So it was great being at Florianopolis, being that Florianopolis is also an island as well, a big island of 600,000 people, bigger than Belize, and seeing that they have a small and large scale composting project was an eye-opener. That is what I liked the most when we went on the visit, the second day, visiting the different composting sites, the projects that they have there implemented as well, is working for them. It's been successful for them. The first visit that we had, I would like to go a little bit more in depth on that. We went visiting a smaller scale, which was community-based, where the community are the ones that they a small neighborhood that drops off your organic waste and do their own composting, still together with the city council together, but it's owned mostly by the neighborhood community. They have ownership on that. We saw what is the technique that they use, and this technique was done by a teacher there at Brazil. I forgot his name. If someone could mention the name to me again.
Dr. Miller.
Dr. Miller, thank you, Alejandra. It was Dr. Miller that implemented this composting, which is for good for Brazil. For the weather in Brazil might not be the best here for Belize, since we have a lot of rain as well. They use hay at the top, which is excellent for the composting. So we visited that. Then we went to visit a larger scale at the transfer station in Florianopolis, which is a PPP project, working together. The private people, the city council pays them a fee, and then they do this partnership project, which is a larger scale, and they sell that composting, so receiving money back from this composting. Then we visited the hotel that is already doing it as well. They're doing their own composting. They took up the initiative to do composting. And then we visited the condominiums that as well. It's a large condominium, and they separate all their garbage, glass, organic waste, inorganic. They have several they divide, and then the city council will pass and pick that up. So all of these projects are, I would say, it's not hard, or it's something affordable that we could start doing, even if it's just here in Orange Walk, and eventually we could do it in the entire country of Belize and get into the circular economy. Another thing that stood out for me personally was that a lot of these island and Pacific islands were doing biodigestion, which is something that we have spoken here with our supervisors, something that we could do, and we could, since we're big in agriculture as well, and a lot of these countries are already doing it, already have projects in doing it. So it's something that, stood out, and something that we could also implement here in Orange Walk. We are going to start smaller here in Orange Walk with our market vendors. We already have a lot of brown waste that the households produce as well, so that it will be also used for the composting. And together, if we could do a PPP project with our ASR, VSR, we could start off by there doing that PPP project. It will benefit both the town council and also the company, because we have that organic waste available here to us, and we're not doing anything with it. And seeing how educated the people of Brazil are, and how big they are on the environment and on climate change. Also being at the hotel, I just want to mention that I saw three of a group of football players were walking past us, and I realized that they had their bins already separated at the hotel, and the kids, they already know. They didn't even have to see which color is for which can, or which one is for the plastics. They already knew, and they just threw it there. They didn't know I was looking at them, but I saw that, it starts with education as well. They have to start at school. So hoping that we could get this going into our education as well, into our school curriculum, starting from very young, because it is nothing hard to do composting. I do it at home, very small, but if we could all do it, imagine all 15,000 households here in Orange Walk produce how much they produce of organic waste, and we could do our own composting. And then they also spoke about the home and school composting, that through the recycled organics, all of these islands and countries received bins. Corozal was one of them that received, and they explained how successful it was, and how giving that empowerment to the community and ownership. Because one thing that stood out in Brazil is country ownership. If you have ownership on something, you will want to do it to the best, and you will make sure that you do that. So the schools were very successful in the composting. I believe Ms. Taris continued to doing that in Corozal. We are hoping that we could do it here with our market vendors here in Orange Rock. And in Orange Rock, a lot of people do not know what is organic waste and what is composting. Yes, maybe they have heard about it, but when we did when I was reaching out to different people, a lot of people do not do organic waste at their composting at their homes, no? So if we could start educating our market vendors, which is what Alejandra wants to go into, tap into educating our market vendors, since we have 2 market areas here in Orange Rock, and get maybe someone from the private to collect that if they want that organic waste, since we don't have our own composting plant. But if we could work with, with the community, teaching the community, implementing. I was at the Despierta Belize, which is a local talk show, and I spoke a little more about the recycled organics, about what was the workshop about, and they wanted us to, someone from our recycled organic to be at the talk show to speak a little bit more in depth about it. So just the knowledge shared, the networking that we shared in Brazil was very excellent. I am grateful for that experience that we had at Florianopolis, and the projects that they are already doing that is successful for them. It did not happen overnight. It took them a while, but I know that if we start from now educating and taking country ownership, which is the main thing, we could do something here in Orange Rock, which is a smaller scale, but will be reducing that, our carbon footprints and everything. So that was the experience that I had in a nutshell. I wish I could speak a little bit more in depth about all the discussions that was made. The connections that was made will be lasting as we come back to our countries. We came back with that back rejuvenated, motivated to continue working with the recycled organics and to continue it after the workshop. So I would just like to give a big thank you to all the organizers and everyone who has been working with the Orange Rock Town Council, as we have had our organic waste management plan finalized, and I can share it with everyone that is here on the workshop right now, on the meeting, sorry, and I will be sharing that with the community as well. And Mr. Baiza, we will continue working to see how we could, reduce that organic waste from going to the landfill. So that was it for my presentation.
Yeah, thank you. Thank you very much, Joycey, and for these words. She represented incredibly Belize, but also the situation that the local governments are facing in Belize. So we thought it was a good opportunity for her to present today, to share with you the different experiences, and also the exchange that could be generated by the peer-to-peer chat. You can share between each other the good experiences that you have been implementing in your own municipality. So it's good. I will stop sharing just 1 second, because to be honest, my battery is low, so I need to change my charger. So 1 second. I will share with you in a while the a QR code where you can see a note that we create, or a blog that we created for this event. So you can see more pictures, you can see what happened in Florianopolis. So here you have it. For more information about the event, you can scan this QR code. Or also you can find information on our website, that it's Recycle Organics, just to let you know. So we will start now with our first presentation. So the first presentation will be about the agroecological farming related to the experience that he had from Uganda. So he's Felix Kawich. He's an agronomist with a master's degree in environmental sciences and resource management from TH the University of Applied Sciences in Germany, and the Autonomous University of San Luis Potosí in Mexico. After completing his studies, he co-founded an agricultural consultancy in Belize to provide technical assistance to farmers. As an entrepreneur, he has promoted conservation-oriented farming practices in medium to large scale operations, focusing on reducing agrochemical use, improving the nutrients use efficiency, and encouraging the crop rotation. His current work emphasizes agroecological farming with smallholder farmers, fostering sustainable and climate resilient agricultural systems. So thank you very much, Felix, for being here with us today and for having us the opportunity to know more about these different cases from Uganda. The floor is yours now.
Good morning, everyone. Well, first of all, thank you very much for giving me the opportunity to be able to share these experiences. Because it was just in a nutshell, it was quite an experience. It was very impactful. So just to give you a brief introduction of the agroecological farming in Uganda and why I was there, is that as part of the German academic exchange program, I had the opportunity to participate in an international seminar titled The Strategies for the Sustainable and Just Transformation of Agri-Food Systems in the Global South. One of the main things here are carried out during the seminar was agroecology. So just quickly, agroecology involves a lot of principles, right? There are 13 principles on it. One of the first ones is recycling, which is converting organic waste into compost, and then improving the soil health. But along with that, there are many other things that come along, such as input reduction, economic diversification. But things that stand out would be the co-creation of knowledge, which is something that was very good about this experience in Uganda. And it's a case that I'll be sharing, which is a community-based, whereby communities themselves are able to identify their problems and then find solutions. And some of these solutions do involve the transformation of organic waste. The next one. So we had the opportunity to visit a farm called Fresh Veggies PGS Uganda, which is a community composed of 60 farmers that are part of the program. So what they do is that they mobilized within themselves to learn, find their problems, and then find a solution. So they have been focusing mostly into what's organic farming and agroecology. They are not a certified body to say that they produce organic products. However, they do follow the ecological principles. And it came out something from the community, which I think in this case is something very important, whereby the community or the members are able or want to transform their behaviors. It's the mindset change that they have to do things better in order to protect the natural resources. By doing so, they're learning from each other. They share their experiences, they share all the knowledge, and find what works best for one another. And the products that they produce, they're basically marketing within themselves. So they had the idea of transforming the entire community on the way they eat. So other than converting organic waste, they're also transforming the community mindset to eat healthier. So in this case, they're eating, let's call it organic or agroecological products, which are healthier. So with that, they're giving that value addition to all these crops. So they focus mostly on the community, change the mindset in terms of production and nutrition, and then they do plan to move forward. The next. So the most common thing that they're doing is the peer-reviewed practices. So what is it that they're doing within them? Everybody has their own experiences. Things will vary from one point to the other. They have different crops. They might have different pests. Some might have different animals. So within them, one of the things that they're doing is using pig manure. I mean, some houses would have a little pigsty behind the house. So they are collecting that manure and they're putting it to compost. But their compost isn't anything very fancy. Rather, it's just a collection point whereby they separate the solids and the liquids. And then they're able to use both of them in different methods in the crop system, right? So it's a very simple method. It doesn't require a lot of investment. It's just knowledge sharing between them. They're also doing composting. And what drew my attention here was that the crops that they're growing, they might have pests, but they now understand what is an economic threshold of having a pest. If the pest is not causing any damage, you leave it. If the pest is causing a lot of damage, then they remove the plant. That plant that they remove from the crop, they put it to compost. And then at the end of the day, they return it as fertilizer to the soil. So they are not wasting anything that is produced from the soil, which was very interesting because usually we would always say, oh, remove the plant or throw it away or let the bugs feed on it. Or in some cases, farmers would be apply chemicals. In these cases, they are not applying any chemicals to it, rather just remove the plant and put it into compost. And with that, they find other alternatives to manage their problems, such as using repellent plants. As you can see in this picture, there's one row that has lemongrass. So that lemongrass is used to repel certain insects. They're also using bioinsecticides and charcoal as soil enhancers. The next slide, please. Here is just an example of some of the practices that they're doing. No, the previous one. Some pictures that were to showcase what they're doing. On the first picture, you can see that they're growing that spinach, and then they have a plastic bottle. It was a very simple method of applying the pig manure to the soil. So they basically dig a hole, insert a plastic bottle, and then in that bottle, they add the manure. This manure would already be dried, okay? So it's not fresh manure that they add, but it's already dried. Through there, they also add the liquid part of the manure that they have, and they have seen very good results with it. One of the questions that we had was a health concern issue of using the manure as is right there. But they have found out that it does not have any kind of cross contamination with the plants. So that was very interesting. And then on the other picture, you can see where they apply the charcoal. One of the things in Uganda was that whenever they build a house, they do bricks, and it's basically a homemade brick. So any residues that they have left over from that brick making, they bring it back to the soil. So they're not wasting anything and just bringing it back. There have been some studies that show that brick, or it's but once composed of clay, I mean, once returned to the soil, it does act as a moisture absorbent. So it basically withholds some moisture and thus improving crop production. So based on that, there are practices that they can do, and they're not wasting anything, but improving their soil health conditions. Next slide. So this on the picture, you can see that is Miss Julie Matovo. She is the founder of this program within the community. And she does have in mind to transform the community based and take it forward to be a part of the participatory guarantee system, which is a certification program globally. And they do plan to expand that. But her idea was always, we have to start with the community. We need to transform everything that we have here and then take an extra step whereby you can expand to markets or even export. They had the plan of engaging more community members and also conduct roundtables and discussions with other stakeholders whereby they can improve the food systems. So this is one of the case study that was very impactful, that I can see that small changes can make a big difference. Next slide. And then we had the opportunity to visit the National Livestock Resources Institute, Uganda. This in Uganda, or this institute has the mission to improve the productivity of livestock sector through the generation of promotion of efficient, cost-effective, and safe technologies and innovations. So within this institute, they have a dairy farm, has the capacity to host 300 animals. And the main waste from animal production is, well, the manure or the cattle dung. So they are basically taking the dung and transforming it all through the process until they have zero waste. So it is a concept model that they developed a couple years ago. They're still in the learning phase, but they're already trying to replicate it at the farm level, whereby they do have certain farmers that are starting to collect the manure and transform it. So from the cattle manure, they're doing biomethane, they produce bioelectricity, they do organic pesticides and liquid soap. Next one. So the institute has the capacity to produce 116 cubic meters of biogas per day. With this, they can produce electricity, and that electricity is basically used to, how is it, to have their operations covered. And they even have a surplus in that case. Because of that surplus, they're trying to find other things to do. With this, they have improved their technology to purify the biogas to biomethane, which is something that they do want to accomplish and be able to transform at 100%. Next slide. So here is just a brief summary of the institute, or the concept model that they have, which is, one is collecting the manure entirely from the stables, and there they start the process of transformation, whereby they have the biogas and then they produce the biomethane. From there, from the biogas tank, like you can see in the picture, that's where they have a biogas generator, and then they have a portion that can be bottled, and they're selling it as narrow biogas. This is being used in households. So they've managed to acquire that technology to be able to bottle it. They still need to perfect a couple of things in order that they can get it to the households, but it's a work in progress. Um, Once they have this biogas, there's how would I say? There's two sections to the manure. After the biogas, then they have like the slurry, and there they have two separations. One which would be the solid biodigestate, and one the liquid form. On the solid one, they are able to dry it, and then they can use it for different for other purposes. The next one. So this is just a picture showcasing one of the biodigester plants that they have, and whereby they use it to produce electricity. The next. And then here is just an example of what they're doing when they transform the solid digestate. Like what I said, there's a separation. So the solid part, once dried, they use it as pellets. They're even using it as a mushroom growth. They're commercializing that to several farmers so that they can grow the mushrooms. They're also doing briquettes with it. And one important part is that it's also compost. I mean, they are using it to produce their own corn in order to feed the animals. So in terms of this solid digestate, they are not losing anything. They're basically transforming every single gram from this. And they have managed to commercialize it to a certain extent, I can say, whereby, like, let's say in the briquettes, they have found out that it does have a higher heat index. Thus, it's better for the households. And with that, they're reducing the use of firewood. The next. And then here you would see a pond, and that would be the liquid digestate from the slurry production. And then this, they're giving it different alternatives. One of the things is that they're producing liquid soap. I think whenever they tell you you're using liquid soap from dung water, you kind of like say, like, I don't trust it. But nevertheless, it's something that works. And they're finding uses to every single part of that waste. Um, They're using it as biopesticides as well. They're seeing good results with it for certain insects. And it can also be used as fertilizers because it does have certain nutrients. They're also in the experimental phase to grow certain algae within that water in order as a nutritional supplement. So they're trying to maximize all the content of the byproducts, uh, which seem quite interesting at that point. One key thing that I like to say is that while standing next to this pond, there was no scent at all. All the scent of cow dung was basically gone throughout the entire process. So, so it gives you that there is a good process or a good transformation of the product itself. Um, so those are the things that this institute is doing in order to transform that cow dung into everything else and have that zero waste concept model. Next one. So I have a question. Would you try using a hand soap made from cow dung? uh, and then they're producing shampoos and other soaps, and what they told us is that it is only waste if you waste it, which was basically true from what they have, right? I mean, you can take anything produced from the environment or from any system that we have and then transform it. But it's being able to have the one resources and two the willingness to transform it and use everything. Yep, that would be.
Thank you so much, Felix. And also, like, yeah, I loved all the cases and the multiple options for valorizing the organic waste, especially the manure. There is hardly to valorize. And also, I really like the presentation of the generation of the byproducts and also the generation of the electricity. So thank you so much, Felix, and congratulations for this enriching trip that you had made. So thank you. Now I will present Pablo Lopez. Are you here, Pablo? So I can present you.
I am here.
Great. So Pablo Lopez is the coordinator of the Recycle Organics activities in the Pacific. He is a chemical engineer with a specialization in energy science and sustainable development, and has 15 years of experience in climate mitigation policy and projects, including more than 10 in methane mitigation from the waste and energy sectors. He lives in Honiara, I hope I say it properly, in Solomon Island, with his wife and 2 kids. So because I think it's 4 a.m., 3 a.m. in the morning for Pablo, we will have him now. We will take a small screenshot after his presentation, and you can leave all the questions you have for him on the chat, and then I will send him back, and you can be in contact so he can rest the following hours. So now, Pablo, the floor is yours.
Thank you, Maria Paula. Hello, everyone, and thank you. Thank you for having me today. I just wanted to share quickly one of the activities that we're doing as part of the Recycle Organics program in Samoa in the Pacific, as it pertains to the agricultural waste. This is part of the educational program of the component of the program, and we're focusing on farmers. The main focus, as you know, of the program is the reduction of methane emissions from waste. But beyond this, we want to develop some capacities around the farmers in Samoa to better use their organic waste, and with this to reduce fossil fuel and firewood waste. Firewood use for cooking. The scale, the scale is much smaller than what Felix was showing us. These are all small farms, either small farms or small crop farms, small pig farms or small crop farms. Some of them are mixed. Many of these are more family farms, commercial, so not necessarily subsistence farmers, but still pretty small scale. You know, the size of the pig pen that you see in the picture, maybe that or twice that many pigs would be more or less the scale, average scale. So so we are the idea is to just provide some training. You know, currently the disposal methods, especially of the pig manure, is not very, you know, technologically advanced, not very sustainable. It is left to decompose, and same with the agricultural waste from crops. It is just sort of piled up on the side and left to mulch. So this way we can create some value on some of the waste that is just utilized. So the idea is to create these trainings and provide some equipment, the equipment that you saw in the previous picture. So these modular small biodigesters to make some cooking gas for the families and the farms to then use. There's a lot of LPG gas sold in cylinders, and people rely a lot on firewood to cook still. So so that's also a co-benefit we can get from this. If we go to the next one, just talking about the capacities we found and the conditions that we found that that we're not starting from scratch, even though biodigestion is not very common or not common at all in Samoa. We did find a lot that we could. First of all, extensive tradition of local consultations. In Samoa and throughout the Pacific, there's still social structures that are rely a lot on the villages, on more informal structures with different committees and councils that sort of report to a village chief, and there is a more formal communication there with the government and the different ministries. So it's a way where you can get to a lot of people through the chiefs that are a bit more invested in the environment or environmental solutions. So through this, we organized some consultation sessions to really hear what their issues were, what they would be open to do, and what they needed to make something like this happen. And then we started working with the government, with different ministries, and some institutional arrangements that were already there and working really well. MAF, the Ministry of Agriculture and Fisheries, has an advisory division that whose job is basically to provide trainings for farmers. So far, they've mostly been focused on different crops and how to deal with pests, but they were very interested in including a training like this. So the idea for the training is for us to provide all of this knowledge to the ministry's team, and so they can include it in the training that they regularly give to farmers all across Samoa. And then there is MNRE, the Ministry of Natural Resources and Environment, where the renewable energy division is the one that deals with biogas production. So there's only maybe some 5 years of experience working with biogas in a more formal way, a couple of different projects that have now 26 systems installed. And MNRE, so the Ministry of Natural Resources and Environment, also has a waste management and pollution control division that are the ones that that deal with waste collection and disposal. So engaging all of these three divisions and all the work that they already did together really made it easy for us to access all these networks of farmers. who were, I must say, also very interested in receiving all of the support. So this is just a map for you to get an idea of the systems that already exist. Samoa is a small country, but much smaller than Belize in area, about half of the population. So these are the two main islands, and it's pretty split between both of them. And if we go on to the next one, I wanted to show some of the lessons that we have learned so far, and that we hope to learn as we continue these trainings. The first project that started installing the first 5 biodigesters were these ones that we see in the picture, sort of not prefab. They had those molds, and then they would actually build the different tanks with cement, which to bring the technology into Samoa and to build it and operate it was very expensive. There was not a lot of knowledge on how to use it. So in terms of maintenance and the operation, there were a lot of issues. And to this date, I think 3 of the 5 are operational. 2 are not operating at the moment. As you know, there's a lot of turnover sometimes in farms. If the person that was operating the system leaves for some reason, there's not necessarily someone left behind that knows how to use it. And there was also the amount of gas being produced was more than what the farm could use, and there was no good way at the time to store it or commercialize it or use it beyond a pipe and some burners. They were using these plastic bags, 1 cubic meter bags to transport the gas. But as you can see, it's not a very friendly way of transporting gas. You can't really take it for long distances. It's hard to have a bag like that next to your house. So the next 20 systems have been these modular systems. And if we go to the next one, we can see it a little bit more clearly. That are much smaller, are very easy to operate, and have created a lot of interest. They're also a bit more suitable for the scale of the farms, and yeah, it's mostly working with the pig manure, mixing some agricultural or food waste that is fed, and there's a system of valves that is connected directly to a stove, and faucet where you can drain the digested to use as fertilizer. So the people have been interested in the trainings that are going to happen now next month, and 20 systems will be installed for 20 of the participating farmers. And all of these new systems will also be included in the current monitoring that the Energy Division of the Environment Ministry is doing to perform some data collection, make sure that the systems continue working, even do some troubleshooting, as they are the ones that have installed the first 20 systems. So there's a lot of knowledge there, technical knowledge on how to deal with them. So this is a brief overview of what the educational component is trying to do in Samoa. Happy to answer any questions if there are any.
Thank you so much, Pablo. I really love that we were able to see here something related, well, first at large scale and now more related to family farmers, and also the need of the train or the capacity, just one second, of the capacities that are needed to be created, and also this exchange with the national entities. So it was super good, and also to understand the different history from the first technology and nowadays how you implemented this, so, or that you are planning to implement this. So I will ask you all if you can turn on your cameras, so we can take a picture of all of us. I will stop sharing 3 seconds, and I will then say bye to Pablo so he can rest. And all the questions you have, please, if he's here, he can answer. In the case he's not, we will send that questions by email and establish a contact between you all. Okay, so, oh wow, we are too much today. Give me 1 second so I can see you all the ones or cameras on. I think it's one hand up. I don't know. Abdel, do you want to say something?
Yes, is
Yeah.
it be possible for us to get a copy of the recording?
Yeah,
I would
sure.
like to share with others, because I know I attended, but I'd like to share this knowledge. This was a lot. This was a lot to take in right
Yeah.
now, and it's a lot of useful knowledge, of how people are
Yes.
doing things. I know you see Pablo is all the way across the world, and we have a similar culture here. I know that we do have places that are raising pigs, and they may not think that they can harvest the methane, so I think by sharing this with others rather than just keeping this knowledge to myself, and the best way would a recording of this meeting would be very helpful. So is it okay if I email you at mpviscardo@ccap.org? Would that be the
Yeah,
best
sure.
email?
Yes,
Okay.
please do that. And also, no, thank you for your comment. I left a link on the chat because we upload all the presentations from our previous speakers and the ones that are today, and also the upcoming sessions. We are uploading all the presentation on our website, just to let you know. And you can have access, but I can send you, of course, the recording for sure. Okay, so now I won't distract myself anymore. If you can turn on your cameras, I will say 1, 2, 3, and I take a screenshot. So, recycle organics, you can say whatever you want. Good morning, Belize. So, 1, 2, 3. Great. Thank you. I have it now. I will share with you in our WhatsApp, and also to the contacts I have. So I know I didn't want to mute it myself. I will continue sharing my screen. We will move forward. Thank you, Pablo.
Thank you, everyone. Have a good day.
Have a nice day.
Okay. All right. Thanks, everyone. Maria, can you please add me to the WhatsApp?
Yeah. Can you send me your phone number by email?
Okay, will do.
Yes. Perfect.
Yes.
Thank you.
All right. Thank you.
Great. So now I will present Adrián Cetina. Give me just 1 second. Can you see my screen, right? Yes?
Yes.
The full PPT? Thank you.
Yeah.
Okay. So, Adrián is a manager of R&D and sustainability at Belize Sugar Industries, where he leads strategic initiatives in variety development, clean seed systems, irrigation, and climate resilience. With a background in agricultural science and a passion for innovation, Adrián has played a key role in advancing sustainability practices and supporting national development efforts. He represents BSI and in multi-stakeholders platforms, and contributes to policy and technical working groups. Adrian is committed to driving impactful research and fostering collaboration across the sugar industry to ensure long-term productivity and environmental stewardship. So thank you very much, Adrian, for joining us today. And the floor is yours. I will move forward to your presentation.
Hi, morning, everyone. Apologies, I need to, something came up, so I needed to take the call on the go. But nonetheless, we're here and I can present the information. Thank you for taking time out, everyone, also for listening to this presentation. Can you go to the first slide? So I'll be talking about our compost operation at BSI. For some context for everyone, Belize Sugar Industries Limited is the mill in northern Belize. The sugar industry of Belize is comprised of two sugarcane growing areas, one in the west, which is Santander, and one in the north, which is BSI. We're supplied by approximately 60,000 acres of cane that produce about 1 million tons annually. As a byproduct of the sugar manufacturing process, we produce two waste streams. One is mill mud, which is all the mud that comes on the cane, and ash from the cogeneration facility. These mill mud is about 35% organic matter. Ash, not so much, it's very low, about 2%. However, it is a waste stream coming out. In the past, we have used the mill mud in the closest farm, which is Tower Hill Farm, and we have applied at the time of replanting. From the data here, you can see that and this is fresh mill mud, this isn't composted mud, that we are seeing, this is historical information as well, sorry, that we see an improvement in productivity over many cycles. See that the Tower Hill Farm that has been applied with fresh mill mud, and the other farms which have not been applied because of distance purposes and making it financially unfeasible to transport that far. But we do see that there is a difference in productivity, and this is statistically significant. So this is how we began to then think, we're seeing good results from applying fresh mill mud. We have this waste stream coming out that is costing the company a lot of money to transport, and we want to improve on our circularity. We should then begin to explore composting. When we began, can you go to the next slide? When we began composting, we did not know, and so I needed to walk you through the journey of how we are where we are. Can you, next slide, please? It's taking a little longer. So a bit of composting basics, and I think everybody knows this, so I'll go over this very quickly. The compost we need to be, I'm sorry, can you go back one slide? It took long here. Right? So to compost, we need to have the right carbon-nitrogen ratio. We all know that if we're above the green, the dark green lines, it takes long to compost. If we are below the yellow line, then we have that smelly compost that we were talking about earlier, that that was a signal of a healthy composting operation when there isn't any odor. We also need to pass through the thermophilic and mesophilic phase. And the image below is an image of when we started you can call it the discovery phase of compost. Next slide. As we move through the the discovery phase, what we found is that yes, indeed, you can compost mill mud, which wasn't a surprise. It was more for us getting familiar with the composting process. And what we found is that the thermophilic phase lasted 75 days, and the curing phase, which is the mesophilic phase, lasted 60 days. So in Belize, in this small experiment, we can produce compost in 4.5 months. And this is turning monthly and applying water when necessary. So now that we knew how to compost, and we knew how long it took, can you go to the next slide? Then we began, I think, Okay, oh, sorry, one more. Then we also noted that the volume decreased by 65%. We also lost 60% of mass, and then our bulk density doubled by the time that the compost process finished. So now with that information, then we began to scale up. We now have a small compost turner, which is for the compost production. After composting, we need to transport to the field. And for that, we need a long bed truck with a loader to transport that out, and then to transport out the compost and the compost application. The at a operational level, compost production is very easy. It's the compost application part that is the most complex part and the most expensive part. And that's another learning lesson that we have here as well. Next slide, please. This is an image of our compost pad when we were in the 2025 season when we were full. You can see some of on the right-hand side were the older compost windrows, and on the left-hand side, the younger compost windrows. Some of them had not been opened up yet, opened with the excavator so that we can come in with the compost turner. In here, it's a good snapshot of the learning that we've done as well in scaling up to this, I would say, semi-commercial scale, because we're still taking about 20% of the mill mud coming out from the factory. You see that sometimes at night in the middle when we're receiving the feedstock, that because they can't see and the lights, you can see the windrows are slightly crooked, and you can see when we're receiving material during the day that the windrows are more straight. So again, I mean, hindsight is 20/20, but these things seem fairly obvious. But these are things that we go learning of when to receive feedstock, when not to receive feedstock, and how to manage our windrows. So now for this crop, I don't have a good signal. So for this crop, what we produced 6,000 tons of compost. In the 2024 crop, we produced 7,000 tons of compost. Why the difference in between the previous crop to this crop? The rationale is that it rained in much more than the historical average in January and February. Therefore, our compost pad was very wet. The trucks that come in have on 10 tons per. So you can imagine a truck that already weighs about 1.5 tons, maybe 2 tons, going in 10 tons, trying to go through the compost pad is an area that was a cane, and we transitioned to a pad, so it'll break mud. So we had very limited accessibility getting in there, and that's why we had reduced compost production in this crop. Now, looking at, now that we have compost, we've produced the compost, and we want to apply, we need to know how much do we apply. Do we need to apply 1 ton, 2 tons, 3 tons, 4 tons? And depending on the way that you look at it, you will apply the different dosage. We elected to go on a nutrient basis application to our fields, is we're trying to fill 3 cups essentially for nitrogen, phosphorus, and potassium, in addition to getting the benefits of using compost and incorporating soil organic matter. From our tests, and very important that these are fertilizer analysis tests, meaning that this is mineral availability. In the 2024 crop, we did the mistake of analyzing as a soil sample, essentially as compost. But what we need is sending it as a fertilizer, because this is then what is available to it, and that is your calculation in the 2024 crop. So based on our lab tests, what we see is that we can supply with 3 tons per acre of compost, we can completely supply our phosphorus demands for a cane growing cycle. Right, one. Then we will need to come back in and top up with nitrogen and potassium. So we're applying at 3 tons per acre. We get fertilizer savings. And so that's reducing our, when we have a cost savings there. Two, we have a saving. We also have, we're avoiding carbon emissions because we're no longer buying synthetic fertilizer at the rate that we normally do. And then 3, we're getting the benefits of compost. We've amended our fertilizer mix to only have nitrogen and potassium. Of course, now these are in trials because we need to convince the commercial farm that migrating to a hybrid compost synthetic fertilizer will not affect the production. Right? The numbers say they should not, but there's still some hesitancy on the commercial side for them to fully move to this strategy. But so far, we are seeing some very deals that implemented this. Now, moving forward, this is my last forward. We're looking to expand from our semi-commercial scale, which uses about 20% of the mill mud from the factory side, and looking to consume 100%. We would expand to 100% of all of BSI's fields, which is approximately 6,400 acres. Also expand our which would go out to farmers and also sell to a project building that active capacity of sugar farm. It's multiple. So the wider farm community will benefit from this. If doing the numbers, we would be able to produce at full scale somewhere around 45,000 tons of compost annually from the feedstock that we have. We have the land to do it. The equipment would not be the acres that need to be applied. With that there, I'll close it off. This is more, it was a little different presentation because it's more of an operational view on things in expanding compost and the way that we look at it. And so looking forward to more collaborating with you guys. I think it's very good that you have reached out to this, and I'm happy that the last slide here, this was just to show you I'll just explain that quickly. We would expect that we have variability within the industry because the cane is coming from from 60,000 acres. So we're going to have a lot of variability in the feedstock mix that we receive. One sample from each windrow, so we know that. Dosage by windrow is difficult, not impossible, but difficult. What we do is we mix windrows and make blends. And we know the blends that we mixed, and so we can then dose out what we need. And that's how we arrived at that 3 tons per acre. Of course, we know with compost, it's not going to be an exact science. We might be applying a little more, a little less, but we know that we're within the range that we want to apply. And so we're in the 3 tons, we're applying slightly more than we would need to ensure that we're applying sufficient phosphorus for the cane growing needs. Yeah, with that, I'll close.
Thank you, Adrian. Thank you so much. So this was a very good experience because of the quantities that were involved, 6,000 tons of compost up to 7,000 tons of compost, and also because they applied this criteria of the nutrients for the application in the soil, and also that they have cost savings because of this compost and of course the mitigation to climate change. So I will give the floor now to Diana so she can lead the Q&A section. But also, I don't know if you have any question to the speakers, you can open your mic and just make the question, or also leave it on the chat.
Yes, thank you, Maria Paula, and thank you to all the presenters today. Yes, I was having actually problem with the chat. I'm not able to write in it. So if any one of you is also having the same problem, please just raise your hand and we can open the mic so that you can ask questions for the presenters. I don't see any yet in the chat or the Q&A, but I wanted maybe to first ask Felix a little bit on your opinion on like the Uganda cases that you shared. Like, how replicable do you think that those practices would be under Belizean conditions? And do you think like farmers have a good perception of using like manure directly on crops, or just processing and using it? How willing are they to adopt these zero waste practices to use organic waste, Felix?
Okay. Thank you very much for the question, Diana. After all right, after visiting Uganda and thinking about Belize, I think some of those practices are highly replicable in Belize. I think it's a matters of changing the mindset of farmers. In our experience here in Belize, smallholder farmers are used to quick solutions. So it's a lot of fertilizers, a lot of chemicals. But I believe that once they learn the value of composting or using any organic waste produced from their farm and being able to transform it, and not just know but understand the benefits that it brings along. I mean, just like how Mr. Zetina was explaining, I mean, by using organic matter in the sugarcane fields, they can reduce their fertilizer inputs and still obtain similar or higher yields. So it's things that farmers need to see as well. But I think there it's that they also have to understand that it's not a quick fix. Using organic waste or composting is not going to give you all the fertility you need in 2 nights. I mean, it's going to be a gradual process, and it's matters of them gradually accepting it and seeing the benefits. So I think it is highly replicable, but it's matters of changing the mindset. In terms of the zero waste concept model that I saw, one, it depends where they produce so much cattle in Belize, and we'd have to see how they would be able to put some infrastructure to collect all that cow dung. But it is possible. I do know of several farmers that are collecting some of that cow dung and putting it to compost and then putting it back in the fields. So it's just matters of educating a bit more, or maybe even enabling the environment for farmers to want to transform all the waste. So based on what I saw, I think things can be done in Belize.
Thank you so much, Felix. And maybe just a question for Adriana as well. So understand, and thank you for like giving us also like all the story of how you started, or you made that decision at BSI to start using that compost. So I understand the compost you're producing is used directly on BSI's own fields. Are there any plans, or are you using all the compost that you're producing? Are there any plans to expand it, the use to other farmers maybe in the area, or maybe commercialize that compost that you're producing, sell it? And if so, yeah, the same as a little bit of what Felix was mentioning. How do you think would it be easy to try to get farmers to start using compost instead of synthetic fertilizers in general in the industry, in the sugarcane industry? Adrian?
So yes, we have plans to expand, and we have plans to expand to utilize streams of the mill. We have a service provision program called AgroPro, which provides planting services and ratoon maintenance to farmers on a credit basis. And so we would be providing compost. We'd give them the option to incorporate compost into their package at the time of planting, or we can apply compost in their ratoons. There's also another project financed by the Green Climate Fund that implemented by the 5Cs. It's the acronym is BACSUF, and they also have it's a climate resilience project, so they have a large soil health component, and they'll be purchasing compost from BSI. So we're going to scale up. In terms of getting farmers to buy in, there are farmers who, a very small amount, who already utilize some of this organic matter already, and they have on an individual basis told me that they have seen good results. So we will need an awareness campaign and a sensitization campaign for everyone to understand the benefits of it. One of the primary cells right now in doing the calculation in the cost to produce compost and selling it with right now with fertilizer prices right now, it is cheaper to apply compost at the 3 tons per acre, and the cost savings that you get there and amending your blend that you will use, you get a much cheaper blend and you have a lot of savings on the dosage that they use. Doing the calculation comes out about, I think, $10 less per acre if you incorporate compost in there, and that includes application of both fertilizer and compost. So that would be the main sell. Of course, right now, compared to last year, the fertilizer price was on a per bag basis, US dollars cheaper. So that holds, but I think that also sheds light on something else, is that with compost, you have a shield against these low fertilizer prices spikes. Because you have your nutrient that you're producing here, the cost of production won't vary much because it's based mainly on fuel. Shield yourself from those spikes, in increases in phosphorus and potassium and nitrogen, due to geopolitical things that are happening. So that's the main sell right now to them, that if you do compost, it's actually cheaper than if you go full fertilizer.
Great, thank you so much, Adrian. Yeah, I think it's a lot, both Felix and Adrian are talking about a lot of disseminating that information now, that it's data that's showing that there is a benefit, financial benefit, a yield benefit on using these technologies and just recovering the waste, that something that would be waste normally. So I think a lot of it is also data collection, sharing that data, sharing those results, and to try to change those mindsets as well. Great. Thank you so much for all of that. I don't know if anyone else has any questions. You can raise up your hand if you want. We have a couple of minutes left. I see someone's writing in the chat. Alejandra is, so I'll leave maybe a couple of seconds to try to see if anyone else has any questions. If not, we will close our session for today and share about our next session as well.
Yeah, thank you. So thank you all very much for joining us today. Of course, you can send us the questions in the case you have my contact or Alejandra's or Diana's, and we can also create this contact between you and the speakers, of course. Remember also that all our presentations are uploaded on our website, and that you can also find information about other educational programs that we are developing in the Caribbean. So the next session will be our 10th session, It will happen on November the 26th. So you will be receiving the invitation. I think some people was having some troubles or difficulties today with the link. So maybe we will figure it out in the case we can create or we can share with you the link and not the registration, of course. You need to register for all the webinars, but also the link of the session so you can join immediately. So thank you very much. Thank you for the speakers of today. I will copy the message from Joe Audinet, that she's saying like the incredible projects underway from Uganda, from Samoa, and also from Belize. So we are glad we could increase capacities related to the valorization of organic waste in the agro-industrial sector. So see you the next month, and we will be in touch. Thank you.
Thank you.
Thanks
Have a
to
good day.
bye.
Thank you, everyone.